Right, Year 12 mathematicians, solving simultaneous equations is one of those GCSE topics that sometimes gets overlooked, but we need to make sure we are on point, ready for our A-level and AS exams. So we're going to have a look at solving one linear and one non-linear simultaneous equation today and make sure that we are happy, because we would often be asked to show a full method. Can't just type stuff into our calculator. So x minus 2y equals 8, x squared minus 3xy minus 2y squared equals 4. The only option we have for an equation like this is to use substitution. We cannot use the elimination method when we have two linear, like we do when we have two linear simultaneous equations. So I'm going to rearrange my top equation here. I'm always looking for the easiest option. So lots of students often say, I'm going to do y equals just because that's what I'm used to. But if I do that here, you can see it's going to make me a fraction. So it's going to make things really difficult when we move on to our next step. We want things to be as easy as possible. So we're going to make this one x equals, because that's going to be nice and simple. So we get x equals 2y plus 8. So there's our rearranged equation. So now we can substitute that in anywhere we see an x in our nonlinear equations. We've got x here, so making sure we use brackets. We've got 2y plus 8 squared minus 3, 2y plus 8 times y minus 2y squared equals 4. So we've done our substitution. So now we're going to do our expanding and making sure we can get a correct quadratic to solve for y. So 2y plus 8 squared, we want to be trying to be efficient about this. Remember, it is a double bracket, so it needs to be expanded in full. But we're hoping we can do that quite efficiently without showing loads of working. So 2y times 2y would get me 4y squared. Then I'd get a 2y times 8 and an 8 times 2y. So that would be 32y when I simplify that together. And then 8 squared gets me 64. So there's my first double bracket expanded. Next one, the way I've written it, I've got my 3 and my y as separate terms, but again, they could go together. So this could be minus 3y, and then when I expand this, it's going to make it a bit easier. So I get minus 6y squared from my minus 3 times 2y and this y here. And I've got minus 24y from my minus 3, 8, and y that I've multiplied there. I've then got this minus 2y squared, and then while I'm here, this 4 that's over on this side, we know we're aiming for a quadratic, we can see it, so we want a 0, so we're going to move this 4 across and make it minus 4 equal to 0. So now we're just gathering our terms together, see what we've got. So 4y squared minus 6y squared minus 2y squared gets me minus 4y squared. 32y minus 24y gets me 8y. And then 64 minus 4 gets me plus 60 equal to 0. Okay, so if I take a look through, I want to have a method, remember, so I can use my calculator if I want, but I've got to be able to show the method that I'm using. So what I would do, I would look through and say I could divide everything by minus 4 to make this as simple as possible to show a method which is going to be factorizing. So if I divide by minus 4, this becomes a y squared, this becomes a minus 2y, and then 60 divided by minus 4 would be minus 15, equal to 0, right? So we've now got a quadratic. We can hopefully see it's a nice simple one. It's going to factorize. So we put our brackets in, we put our y in both, we're going to have 1 plus and 1 minus. So multiply to make 15, difference of minus 2 is going to have to be minus 5 and then plus 3. So minus 15 and minus 5 add 3. So we get our two solutions for y. So y is equal to minus 3 or y is equal to 5. Once we have those, we can go back and find our x values. Remember, using our rearranged equation. So we've already rearranged it. We know x is equal to 2y plus 8. So for y equals minus 3, I have x equals 2 times minus 3 plus 8. So minus 6 plus 8 gets me 2. So I have one pair of values, which is y equals minus 3 and x equals 2. Go and find my other one. So when y is 5, we know x is going to be equal to 2 times 5 plus 8, which is going to get us x equals 18. So our two pairs of values, and it is often nice to write them together because it does matter which pair goes with which. So I have x equals 2, y equals minus 3. So that's one pair of solutions. And then x equals 18, y equals 5 as my second pair. So we need to be able to show that method in full, because they will ask, including this substitution here. We might often be asked to demonstrate that as part of our method. We can't just pull these answers for x equals 2 and x equals 18 out of nowhere. Got to make sure we're showing our method so we get all the credit that we deserve for our hard work. Okay, so hopefully our simultaneous equations are on point. Subscribe for more content.